Can you hear me?
Yes, I can hear you, Stu.
Okay.
Can you see the screen now?
Yes, I see it now.
Oh,
Awesome.
great. Okay. All right, let me pull up some things. Okay. All right. So let's get started, guys. Let
How
me
do
know
I, can I, is there a way for me to go back to my screen to look at the files?
to look at your screen on your computer.
Yeah.
I mean, you should be able to do that. I mean, just come out. I mean, just minimize maybe your Confer Zoom app, or just exit the Confer Zoom app if maybe you made it full screen. So minimize that, and then you should be able to go back to your computer.
Okay. All right, I figured it out. Sorry, thanks for
Okay,
waiting.
nice. Yeah, all right, guys. So you can ask me questions.
Hi, Mark. Morning.
Hey, hi, morning, Nick.
Well, I had a question on a redox problem.
Read off from is it
Yeah, it's from the
worksheet?
exam, the worksheets, or not the worksheets, the extra problems that you gave us, the multiple choice.
Yeah. Okay, so balancing redox equations. Which problem?
It's farther down. It's on the last page. Actually, that one would work. Any of the acidic ones, really, where you have to use the half reaction method, like
Yeah, so
number
for
5.
all of them, you use the half reaction method.
Okay.
So half reaction method is where you divide your reaction into halves, right?
Yeah.
So if you want to pick, let's say, the first one. So you're given, so first step, what you can do is if you remember steps, you can tell me the steps.
I remember you split them in half, right?
Right. So, oops.
I have the steps right now. I just was confused on a few different things when I was trying to do the lab.
Okay. Do you have like a specific problem or just any?
Just the steps. I was really getting confused with so I feel like I may have written down the example that we did in class wrong
Maybe
with the
that's
steps.
possible. So, you can see how I divide this into two halves. That makes sense. So we know that Cr2O7 will go with Cr.
Yes.
So then this oxygen must go with H2O2 because they got to make a pair, right?
Yes.
So the very first thing is that you balance the non-oxygen, non-hydrogen atoms. Now in this case, we don't have any of that, right? So the best thing will be to start with oxygen.
Okay.
Because you start with oxygen before, if there was some other like iron, manganese, chromium, we'll start with that. But for this half, there's none of that. So we'll start with oxygen. And oxygen you can see is already balanced. There are 2 N2 oxygens, right?
Yeah.
So what is the next step? You balance what?
Balance oxygen. Well, it's already balanced. Balance hydrogen by
Balance
adding
hydrogen by adding
H plus
H plus. So which side should I add H plus?
to the right side.
The right hand side. And how many?
Yeah. 2.
2. Yeah. Right. So we're gonna add 2 H plus. Okay, so after we balance all of this, what do we balance next?
Electrons.
Right. So we want to balance a charge, right? By adding electrons. So which side do we add electrons?
To the H2O.
So the way you should remember this is we add electrons to the more positive side.
Oh, okay.
That's how you got to remember this. Okay.
So
add
cancel
electrons.
it out.
Right. Add electrons to the more positive side, okay. so that the charge is equal on both the sides.
Okay.
Okay. So if you look at this side, H2O2, what is the charge on this side? See, there's no charge. You see on top, there's no charge.
Okay.
O2 is 0, right?
So it's a
Two,
zero
right, Amon?
charge.
Oh, okay. I was getting mixed up with the oxidation.
Yeah. So you don't have to do that actually. You
Okay.
don't have to find out what is getting oxidized, what is getting reduced.
Okay.
Okay. So zero charge. And then on
Now
the
you
right hand
have
side,
2
what's the charge?
hydrogens, so that's positive 2, right?
Yeah, so this is positive 2 charge. So what was the rule? You add electrons to the more positive side, right?
You
Mm-hmm.
need to add
Which
2
one is the more?
electrons to that side, right?
Yeah, so you add electrons to the +2 side.
Okay.
That makes sense to you?
So yeah.
So you're gonna add 2 electrons on this side.
Okay.
So just to avoid any confusion, I'm gonna erase these numbers.
Quick
Okay.
question, Amon.
Yeah.
The reason why you add the electrons because you want the 2 positive H's to cancel out, right? To be 0 like the other side? No.
Right. Because the other side is 0, this side needs to be 0. If this side was +1, this side will want to be +1. The goal is not to become 0. The goal is to become equal.
Okay.
Okay?
Okay.
Yeah.
All right. Now we're going to deal with we're done with this side. That's the last step, okay?
Okay.
Now we go to the other side and do the same thing. So you tell me, what should we balance first?
So we're gonna add.
Before
So
doing
balance
oxygen, you got to balance something else.
hydrogen atoms,
No, I
non-hydrogen
don't see
atoms.
hydrogen.
Okay.
So the first rule after you divide this into 2 halves, the
Mm-hmm.
first rule is that you're going to balance the non-hydrogen, non-oxygen atoms.
Okay.
Okay?
So we're gonna balance the right side.
Yeah, so we need to balance, on the right hand side, of course, we need to balance chromium, right?
Okay.
Does that make sense? That we need
Yes.
to first touch chromium. We're not going to touch oxygen. There's no hydrogen.
Okay.
Okay. So chromium, there are 2 of them here, and then there's 1 chromium. So how do I balance that? You can just put 2 in the front.
Yes.
See, when you're going to balance the non-hydrogen, non-oxygen atoms, you can put the coefficients in the front and balance them. You cannot do that with oxygen or hydrogen. For oxygen, you must add water. For hydrogen, you must add H+. You cannot
Okay.
put numbers in the front to modify them.
Okay.
Okay. All right. So CR is balanced. After that, we need to balance what? What else do we have?
Balance O by adding H2O.
Right. So you're going to balance O by adding H2O. What side should I add H2O?
To the chromium side.
To the right hand side?
Yeah.
And how many water should I add?
7.
7. Okay. So this balance my oxygen. And now what's our next thing to balance?
So then you would also add 8 electrons with it, right?
Not electrons. You're running for. You're missing one step.
You balance the hydrogen on the other
Balancing
side.
hydrogen. Right.
Okay.
So how many hydrogens
14.
should I add?
14.
14 H+, right?
Yes.
Okay. So now our atoms are balanced right now. Just the atoms. I'm not talking about the charge. Atoms are balanced, right?
Mm-hmm.
Okay. So now we're going to balance the charge. See, first you balance the non-oxygen, non-hydrogen atom. Then you balance oxygen by adding water.
Okay.
Then you balance hydrogen by adding protons. And then you balance the charge by adding electrons.
Okay.
So you got to remember these 4 steps.
And then so the charge would be.
Right. So now let's figure out the charge. You can pick any side you want first.
So that's -2, obviously, on that
So this is
side.
-2, yeah. And then, but there's also this 14H+, right?
Okay.
So what's the charge total charge on this side?
+12.
Plus 12.
Yeah.
What's the charge on right hand side?
Is it +3?
Yeah, so there's +3, but there are 2 of them, right?
So it's +6, right?
It's +6.
So that -1 is just showing where it is on the periodic table then, right? That's just
What -1?
CR -1. It says CR -1 3.
Well, that's not -1. That's I'm sorry. That's a
okay.
+3.
Okay. Sorry.
That's a positive sign. So you see that chromium 3+?
Okay.
Yeah, so that's chromium 3+.
Okay.
And I have 2 of them.
So that's 6.
That's 6.
Okay.
See, when you're balancing redox equations, don't worry about their charges from periodic table. Just forget about them.
Okay. I didn't think that it was -1 on the periodic table. I was
Okay, you're
was
just thinking that.
confused.
Yeah, it's just fine.
Yeah.
Right. So let me just go back and write that down again. So that was +2.
Okay.
So this is +2 and this is +6. Where should we add electrons?
wait.
Steve?
It was
You should
plus
have
12,
plus
wasn't
12,
it?
right?
Oh, +12.
Plus 12.
Right.
Yeah.
+12. Okay.
You need to add 6 electrons to the positive 12 side.
Right.
Yes.
So why are we adding to the +12, not +6? Because you add electrons to the
More positive
positive
side.
more positive side. So I need to add
Yeah.
6 electrons, right?
Okay.
So I need to add 6 electrons. So I'll get rid of this 12 and this 6 so it doesn't confuse us. So this is good, right? This is balanced. We got 6 electrons here, and here we got 2 electrons. Now there's a checkpoint here, and the checkpoint is?
We have to get rid of all the electrons.
Yeah, they have
so
to be on opposite sides,
opposite
right?
sides. That's our checkpoint,
Okay.
right. So here the electron for this half, it's on the
Mhm.
left-hand side. For this half, it's on the right-hand side, so that's a good sign.
Okay.
Okay. Now our job is to make them equal. So how do you think we can make them equal?
You can just multiply 3 by that one and it's equal.
So yeah, so this side, right?
You're making the electrons equal?
Yeah, you're making the electrons equal. So this is 2 electrons. This is 6. So I need to multiply this side by 3. I cannot just multiply electrons by 3 because that will mess up my whole balancing the charge thing, right?
Yeah.
So I need to multiply the whole equation by 3, just
Okay.
like you do in math, right?
Yeah.
Yeah, so now the problem can be sometimes, imagine, Stephen, this is, let's say, 4, and this is 6.
Mm-hmm.
Then you have to find like a common number that you can multiply both the sides by so that you have equal numbers. Like if this was 4, let's say this side was 4 electrons and this side was 6 electrons, then I'll multiply this by 4 and then we'll multiply this side by 6 so that I have 24 electrons on both the sides.
Okay.
So in some questions you have to multiply both the sides. Some questions you have to just multiply one side.
Okay.
Okay. So in this case, this was easy because we can just multiply one of the sides. Right?
Gotcha. Yeah.
Just multiply by 3 and we're done. But sometimes you're going to see where you have to multiply both the sides by a number to make them equal to one number.
And when you multiply each of those by 3, you just put the 3 on the outside of, so it's like 3 H2O O2 and then 3.
Right. Yeah, you'll
Okay.
put number here in the front.
Okay.
You'll put as coefficient.
Gotcha.
Okay. So let me rewrite this. And again, always rewrite these. Never trust that you're going to remember to multiply them.
You recommend to rewrite them so we can also see what we're doing, correct?
Right. So I got 3H2O2 giving you
3O2
O2.
plus 6 hydrogens.
Right. So 2 times 3 is 6.
Is it wrong to write H6O6?
Where? Oh, here?
Like, yeah.
Yeah, that's definitely wrong.
Okay.
See, this is H2O2. H2O2 is hydrogen peroxide.
Yeah.
And H6O6 does not even exist in nature.
Okay.
So what you're trying to say is that instead of having 1 hydrogen peroxide, I need to use 3 hydrogen peroxide.
Okay.
That's what that 3 in the front mean.
I got you.
That number 2 in the bottom, that means I have 2 oxygens connected to 2 hydrogens.
2 of them together.
Right, together. Right. So you can never change whenever you're balancing, you can never modify these numbers.
Okay.
You can only put numbers in the front. That's all what you can do. Okay.
Yeah, makes sense.
All right, and then you also multiply 3 with this 2 electrons, so you got total 6 electrons. Right?
Mm-hmm.
Okay, and then we can deal with the right-hand side. We're not doing anything to it, so we can actually simply just add it. I mean, we don't need to rewrite that because we didn't do anything to it. Right? So this we multiply with 3, this we didn't touch. So now we got our whole thing. Now what we need to do is you need to add this side. We need to add these 2 equations.
Okay.
Now, how do you add them? The way you add these is that you're going to take the left-hand side and you're going to add it to the left-hand side. Okay?
Okay.
Then you're going to take the right-hand side and then add it to the right-hand side.
So they can cancel out?
Right. So you can cancel out the electrons at the end. The idea is that you're only going to add left to the left and right to the right. That's what you got to remember.
And that's even when you're breaking this equation down to two, right? You're always doing the left and the left and the right and the right. So like H2O2 goes with O2.
H2O2 goes with O2, right?
The very first step when we
The
first
very first
broke
step, yeah. When you do it into two halves,
hmm
right. That you're just trying to match.
Okay.
So H2O2 and O2, they don't necessarily match, but Cr2O7 matches with Cr3 plus. So I know that's a pair because the
Okay.
common thing is chromium. And then I decide, okay, H2O2 must go with O2 then. And most of the times it's easy to figure out who should go with what because you're going to see like the same atom, Cr2 and Cr
Yeah.
in chromium. So they go together. And then the other
Okay.
two go together.
That makes sense. Okay.
Okay.
I was confused on that part as well because I was thinking you had to do the two positive together.
Oh,
and
no,
the
no,
two
no.
positive, negative. And
Just the one that matches with their atoms, those are the one who go together. So if you
Okay.
very quickly try it on something else, can you tell me how should I pair these? The sixth one?
It'll be TeO3 with the
Yes.
T. And then,
So yeah, this guy will go with this guy, right?
mm-hmm.
And then N2O4 will go with NO3 minus.
Yes.
So you're just looking at the similar atoms. That's it.
Okay.
Yeah.
Makes sense.
Right. So now let's rewrite these. Again, the way you're gonna add is 3H2O2 will be added to what? Steven, can you tell me where should I add?
Cr2O7 negative.
Right, you got it. And then 14H plus, and then 6 electrons, right?
Yeah. Yes.
And then if we do the arrow again, then I'm going to write that right hand side. I'm going to start from here.
Okay.
So 3 oxygens, 6H plus 6 electrons, and then
the left or the right side.
on the right side is Cr plus 3 and 7 waters, right?
Yeah.
Okay. So now, now you got to just see what things can we cancel out. Okay.
Okay.
Electrons.
Right. So the first thing is electrons. Electrons must cancel. You should never be left with electrons. If you're left with electrons at the end, there's definitely something wrong.
Okay.
We can get rid of hydrogens.
Yeah. So we'll go one by one. So next thing is H plus. You got 14H plus here, and then you got 6H plus. So all these 6 will be gone. So you're basically subtracting 6 from both the sides.
Okay.
You're not dividing or multiplying anything. Okay. Subtracting the smaller one from both the sides. This 14 then should become what?
8.
8. Okay.
H plus.
That makes sense?
Yeah, definitely.
Okay. So anything else? No, right?
What about H? Oh no, that's just H2O. Yeah. Okay.
That's H2O2. That's O2. This is Cr2O7. This is Cr. And H2O. This is just H2O, right? So yeah. So nothing else cancels, right?
Yeah. So you just rewrite it.
Yeah, you just rewrite it. 2H2O2 plus Cr2O7 negative 2 plus 8H plus gives you 3 oxygens and 2 Cr plus 3 and 7 H2O. Right?
This is a basic one, right, Amon?
No, this is acidic.
Oh, okay. Because I was about to say, if it's basic, don't you have to
Right.
add the O to the hydrogen?
Right. So wait. Don't jump the gun. Wait. Okay. All right. So this is the answer. If the question was acidic condition.
Okay.
Which I'm not going to ask on the test. What I'm going to ask is basic condition. And for basic condition, you do all of this. Whatever you've done so far, you got to do all these steps. So we didn't waste our time, okay? But we need to add 2 more steps if it's a basic condition.
I think I have those written down.
Okay.
So you have to add hydroxide, right?
Right, you have to add hydroxide. So you need to add hydroxide. You got to add them on both the sides. That's one thing. And the second thing is that we should know that how many to add.
Okay.
So who's going to decide how many we add?
The H plus.
The H plus, right. Right. So for basic condition, we look at this H plus and we see, okay, this H plus, we have 8 of them. So if I have 8 H plus, I need to add 8 OH minus.
Okay.
Okay, and you see, since you're balancing these, I cannot just add 8OH plus 8OH minus on left hand side because that's going to imbalance my oxygen, my hydrogens, and my negative charge, right? So I need to add 8OH on both the sides.
Okay.
You cannot just add it on one side. That's the key. Okay.
So plus 8 OH minus
So
on both
but
sides.
it's a basic condition, okay?
Okay.
But it's a basic condition. You do one more step. I mean, basically it's two more steps, but you have to add 8 OH minus on both sides. Okay.
Okay.
And then you can see that this 8H plus and 8 OH minus is going to make water. So if I rewrite this, this is actually 8H2O.
Okay.
You're gonna see that, and that's not visible. Okay. So if I have an H plus and I add this to an OH minus, this will give me 1H2O, right? So if I take 8 of them, then I'm going to make 8 waters. It's 1:1:1 ratio,
Okay.
right? So what we have right now is 8 waters, and then we just rewrite the whole thing again. 3 oxygens plus 2 Cr plus 3 plus 7 waters, and then you must be realizing that now we can cancel water because there's 8 water and 7 waters. We didn't have water before, so we didn't cancel it, but now we made water, so we got to cancel it, right? So how should I cancel this?
So there's going to be 1 water left on the left side.
Right, so this is all gone, and here we have 1 left, 1H2O.
And then that's it, right?
And that's it. That's your final answer. If you want to rewrite that again, you just copy that again with just 1H2O.
Just 1 H2O.
Right.
Okay.
Right.
Awesome.
So with basic amount, you want to make sure you have the proper amount of waters, right?
You have what?
The proper amount of waters for the final step for basic
Not just
redox
proper amount of
equation.
water, proper amount of everything.
Right, exactly. But okay.
So now at this point, if you have time on the test, make sure that everything's balanced.
So, like your whole equation?
Yeah, we can make
Okay.
sure that. So this is a question that you can actually verify at the end when you're done, if you did it right or not, if you have time on the test. So let's see, okay? How many hydrogens do you have? 3 times 2 is 6.
6.
And then I've got 2 here, right? So that's 8. And you can see here I have 8H. I'm just looking at the atoms, okay? Don't worry about the charge right now. We'll take care of the charge later. Then I've got 3 times 2, 6 oxygens, and then 7 oxygens. That's 13 oxygens. And then 1 water, 14 oxygens. Right?
You're right.
14 oxygens. Here I've got 6 oxygens.
And then 8.
And then 8. And that's also 14.
Okay.
Then I've got 2 chromiums. I've got 2 chromiums. And I think everything else we just checked. Okay?
Yeah.
So everything's balanced. Now the charge. This is no charge. This is -2. So I have -2 charge on the left hand side.
Okay.
Right? Let's look here. This is 2 times plus 3, that's plus 6. And then I have 8 negatives.
Oh, okay.
Right?
Yeah.
So this is also negative. -2.
So it's balanced.
So it's balanced. So my charges are balanced and my atoms are balanced. If they were not, I can go back and redo the question or check where I did wrong.
Okay.
Okay. So that's your final check that you can verify the answer. The very first check always has to be that your electrons are on the opposite sides. That was the first checkpoint.
Yeah.
Okay. The second checkpoint is that your electrons must cancel. Like 6 to 6. All should be gone. There should be nothing left.
Okay.
And after that, you should be fine.
Okay. Cool. Thank you.
Yeah, no worries, man. All right. So you guys have any more questions?
Yeah, I do.
Uh-huh.
Are you covering thermal chemistry in this office hours? These
Yeah,
office
sure.
hours I'm on?
Yeah.
Because I
I'll
was
have
starting
it
on your
not fixed to any topic. You can just ask anything.
yeah. Because I was asking because I was doing some of this last night. Can you do number 13 on the thermochemistry worksheet?
So thermochemistry worksheet.
The one with delta H and K joules and all that good stuff.
Just give me a second, okay?
Okay.
All right, so you said number 13, right? Okay, so we have not covered this yet, so don't touch that right now.
No.
Yeah,
What
number
have we
12,
covered?
13, right?
Yes. What have we covered then?
What have we covered?
What was different about that? It was just with combustion.
Number 13, you said? This one? Yeah, see, this one, what we have not covered is how to find delta H if you're given the delta H for the reaction.
Oh, okay.
Now, remember I said in the class that there are 3 methods from where you can find delta H?
Mm-hmm.
And then all of them will be on the test. This is one of them.
Okay.
And we're going to be learning that tomorrow, Monday in the lecture. We're going to learn how to find the enthalpy change using Hess's law. So if you guys want to study that beforehand, that'll be great. But we'll be covering that tomorrow. But what you can already work on is you should be able to work on number 1, number 2, number 3, number 4,
5, right?
number 5, number 6. And after that, skip all of that for tomorrow. And then, yeah. And then you can
Number 30 we
start
went over,
number.
right?
What number?
Did we go over number something like number 30 or no?
Yeah, just give me a second, okay? We'll go one by one. Yeah, and then if you look at number 15, this also, you can work on 16, 17, 18. So 16, 17, 18, 19. Writing that down, guys?
Yeah.
Yeah,
Okay.
because I worked on 17. I worked on 16 through 17 and 20 last night.
Yeah, and then you can do 20. We didn't cover that yet.
Which one?
Number from 20 onwards.
You 20
so
onwards?
Skip 20, 21, 22, skip 23, 20. By skip, I mean just skip for today.
Yeah.
25, 26 also we didn't do. 27 we didn't do. 28 we didn't. 29 we didn't. And then 30 we didn't. 31. And then start again from 32.
Okay.
32, 33, 34, 35. And that's what we have done.
Okay. What's the quiz going to be on tomorrow?
So it will be on whatever I have covered in this chapter.
Okay.
So I'll cover. So tomorrow I'll finish this chapter.
Mm-hmm.
So everything from this chapter, you're gonna. I'll give more details in the lecture tomorrow. So you're gonna see certainly a question like the one that you see from number 32 to 35.
Okay.
One of that question you're gonna see, and then one of the questions that I ask you to skip right now, which will be from number. Where is it? Remember
you said 10,
number 13.
right?
Yeah, these ones. Yeah.
Okay.
Yeah. So like number 10 onwards, like 10, 11, 12, 13, 14, 15, 15. Yeah.
So that'll be on Wednesday, actually, right?
So yeah, I'll post a quiz on Tuesday. And it'll be due, I think, on Friday or Saturday.
Oh, okay.
Friday or Saturday.
Yeah.
You're
I
not
was
going to be doing
intending to
Sunday.
do it this week, but I changed it. I
Yeah.
wanted to cover this one more topic, and because you're going to see a question on that as
You
well.
don't think it's going to be due Monday before class, or?
Yeah, Mondays. No, not Monday.
It'll be
I'm
due
opening it
Saturday
on
then.
Tuesday. I mean, I can keep it till. It doesn't matter to me. It's just that I can keep it till Sunday. I don't care. I mean, I can do Sunday as well. Your exam is on Wednesday, right?
Yes. It's on the 24th, which is Wednesday.
Yeah. Yeah. So I can keep it due on Monday.
Okay. Aman, you can go. You said that we could do 16 through 19, right? Right now,
Yeah.
because that's what I did last night.
Okay.
For number 16, we use the MCAT formula, right?
Or number. Yeah, all these questions are MCAT questions. Yeah, number 16.
Because the way I wrote it down, I wrote down Q equals 15 times 0.13 times 37 minus 22, and I got 29 joules.
Right. Yeah, that's the answer.
Really?
Yep. Q
Okay.
is D, and you got that D, so that's the answer.
So that's just the way I do these ones right here, or no?
Yeah, that's how you got the right answer, right?
Yeah, the one I didn't really quite understand was 18 and 19, just to be honest with
18 and 19.
you. I know you use the MCAT formula too, but it's a little, I didn't really quite understand that one too.
Right. So these questions go one step ahead. So this question is saying that if you have a sample of aluminum metal absorbs 11.2 joules of heat, upon which the temperature of the sample increases from 23.2 to 30.5, and says that since the specific capacity of aluminum is this much, what is the mass? So it's just, actually, this is not a complicated question. It's very straightforward. So it says so you tell me what is given to us.
Well, joules is given to us,
So what is that?
which is our temperature, right?
No, joules is not temperature.
That's
Temperature is in Celsius.
right.
Joules is heat, right?
Joules is heat.
Yeah.
And it clearly says that here.
Yeah. Well, that's our heat. And then we're given our temperature interval and our final temperature.
Right. So you're given initial and final temperature. And 30.5. And then what else are we given? Are we given anything else?
And we're also given
Specific heat capacity.
Right.
we're given C. We're given C as well.
Yeah,
right?
so C is 0.90
Yep.
joules per gram. And you see this guy is very smart. It says Kelvin. You see that?
Yeah.
So you can either change your temperature to Kelvin and find the difference.
Okay.
Right? So you can change both of these to Kelvin and then find their difference. Or you can simply find the difference and change that to Kelvin. Or you can change that Kelvin to Celsius, which is going to be hard, so don't do that. Yeah, changing that will be...
Because the way I did it, Aman, is I put M equals Q over cat.
So Q equals MC delta T. The question is looking for M. So you did Q over C delta T. That's right. Is that what you're saying, Nick?
Yes.
Yeah, that's right. But you see that our units don't match?
Right.
That's the important thing to notice here.
Okay.
That these are both Celsius, but my C is 0.90 joules per gram Kelvin.
Right.
Right? So that means I have to change my temperature to Kelvin.
Right.
Right? So how do I do that?
Did you have to
So did you find the delta T?
Yeah,
Delta
delta
T
T
is 7.3 degrees Celsius, right?
Yeah.
How do I change that to Kelvin?
Added to 273.15. That's how you change it to Kelvin.
So 284.5 Kelvin. So now you got to plug everything in. Q is 11.2 joules. and then my C is 0.90
Mm-hmm.
times my delta T is 280.45. So now if we solve the whole thing,
Wait, so the difference between those two is 280? The difference between the two temperatures? Is that what you're saying?
the difference between them in Kelvin, is that right? Oh, I think we have to first change them to Kelvin, and then
And then
find
find
the
the difference?
find
Because the difference should be like the same,
yeah, yeah,
technically.
you're right. You're right. That's very stupid of
Okay.
me. Yeah, yeah.
Cool.
Yeah, so you're not going to be doing this.
Not doing it that way.
No. That's right. I think I mentioned that in the class, and I myself forgot that. So yeah, you
As
got
the
to
saying
change.
goes, we're
You
all
got to change it
students
to
in this life.
Kelvin, but then the difference stays the same, and that difference was how much?
7.3.
That 0.3,
7.3.
like how you said.
Right, 7.3. So yeah, now you gotta plug that into your calculator. 1.7.
Yeah, that's what I got.
Yep. So B.
Is it the same thing too with number 19 as well?
Number 19.
Because we're trying to find the final temperature this time, but we have grams. We have the
Yeah, so you're basically given all
temperature
things, but
interval.
one thing is missing, right?
Yeah.
So you're given that the mass is 4.5 grams, and then temperature is 25 degrees Celsius, and then you're given Q 133 joules, and you're asked the final temperature. You have the initial temperature.
Mm-hmm.
Right. So if you again use the same formula, you're also given the specific capacity, which is 4.18 joules per gram Kelvin.
Mm-hmm.
So you're using Q is equal to MC delta T, but we know delta T is TF minus T initial, right?
Mm-hmm.
So you can keep that separate for right now, TF minus T initial. And we can do Q over MC, right? So this I'm keeping on one side for right now. And then if I want to find TF, then I know if I have Q over MC, I will have to add the TI to it, right? Or what you can do is you can open these, split them into each one, and then whichever way you find comfortable, that way you're going to isolate that TF.
Okay.
Okay. So let me do it that way. So let's do, if you're more used to that. So Q is equal to MC TF minus MC TI.
Mm-hmm.
And then you have to isolate this TF. I mean, again, whichever way you find comfortable, that's how you're gonna do this. Whichever way you guys learned it in your math, how you're going to isolate that TF, you're going to isolate that TF.
Okay.
But remember that delta T is TF minus T initial, not T initial minus TF.
Okay.
All right. Did you find the answer for this, Nick?
Yeah, the answer was 32 point. I actually got 30.7, but I rounded it up to 32.1, which was the answer.
How much did you get actually?
I got 32.07, but I rounded it up to 32.1.
Okay, yeah, that should be good. All right. You guys have more questions? Something different?
I have a question. It's kind of similar to what you were just doing, but so you went over the equation PV equals nRT. We have to know how to derive that and figure out what formula we need, right?
How to drive PV is equal to nRT? That you don't
Well,
have to drive.
well, we have to know how to get different formulas from
Yeah,
that,
yeah,
right?
yeah.
So there was one I was confused on. Let me see. I think it was. Sorry, I'm looking at my notes. It was when you had like T2 P1 V1 over T1 over P1 V1 over T1.
So let's
Was
say, okay, so let's say that there was a question where, let me start from the scratch, okay? So let's
Okay.
say there was a question where only P and V were changing. Everything else, the question didn't talk about or said it's constant. By that I mean the moles were not changing and temperature was also not changing, or the question just does not talk about them. Okay.
Okay.
In that case, my formula will be P1 V1 equals P2 V2. How you can remember this is the one that are together in your equation, PV is equal to nRT, multiply them.
Okay.
The ones which are on the opposite side, let's say in my question, only V and T were changing, then my equation will be V1 over T1, not V1 times T1.
Okay. Yeah.
So since they're on the opposite side, I'm going to divide them. Right? So now let's see if P, V, and T, all three are changing. Then what should my equation look like?
It would be PV over T.
So P1 V1 over T1, right? Will be equal to P2 V2 over T2. So whenever you're given these type of question where things are changing, like earlier it was this, now it's this, that's how you derive your equation. You can simply memorize them if you want, but I think this is easier that you know how to isolate. I mean, you know how to make a formula, right?
And then from here, if
Right.
you're trying to find T2,
right? So if you're trying to find T2, right?
That's where I'm getting confused when it starts getting different.
Okay, it totally depends on how you prefer to move these around. You can have your own method. The one that I like the most is to crisscross.
Okay.
Okay. Since everything is multiplication division, we can simply do crisscross. So what I can do is I can take this T2 and make it reach here. Why do I want to do that? Because I'm trying to isolate T2. That's why I'm starting with T2.
So, okay.
So what will this become? T2 P1
P1
V1
V1
over T1 equals P2 V2.
Okay.
At least my T2 is at the right spot right now, right?
Okay.
Now the next thing is you can move this T1 up here because you're again isolating T2, right? So T2 P1 V1 equals P2 V2 T1.
Okay.
Right? Now my next thing is that I want to isolate T2, right?
Yes.
So T2, for that, what should I do? I should take this P1 V1 and bring it down here.
You just divide it by both sides.
Yeah, so I should take this guy down here. So P2 V2 T1 over P1 V1.
Okay.
That's how you isolate it. Now, I showed you this in 4 steps. I would usually just do it in 1 step. I'll take this T2 up here. I know this T1 has to go up there. I know this P1 V1 has to come down here. So what I'll simply do is T2 goes up here, P2 V2 is staying there, P1 V1 is coming down here, and T1 is going up there. You see in just 1 step you did all that. Rather than, I think, doing the other way, which a lot of students like to do, is to go, first you divide both the sides and you multiply both the sides. I think that just takes too much time.
Yeah.
If you like that, you can work on that if you're more confident with that. But if you can get a hold of this, it's not going to help you just in this class, but in your future classes as well.
Yeah, I like the crisscross method. That works.
Yeah.
Okay.
So Amon, when would you basically? I know I already got the P equals and RT stuck in my head. But when would you use the P1 and the V1 and the T2 formula, like the one you're showing?
When do you use them?
Yeah.
Yeah, these are the ones that you use when you're given a question where things are changing like earlier it was this. Let's say earlier remember I was giving this example all the time in the class that you are in Menifee and then you're going to the Big Bear.
Mm-hmm.
Right.
See, the conditions are changing, pressure changed, the volume must change.
So if they're asking for the second time or something like
So
that,
they're asking you, okay, earlier it was this, now it's this.
Mm-hmm.
So what do you think happened to that? So there was like condition A, and then there was condition B, right? And we were calling that like P1, V1 was the condition when you were sitting in Menifee. P2, V2 is a condition when you're sitting at Big Bear. So if you want to see an example, see if there's if I put anything here or not.
Amon, real fast, that's the most that we're ever going to have to switch up that equation, right?
Yeah.
Okay.
Yeah. Is there no question here? I think it's in your exercise that I gave
Which
you.
exercise is it? I think or K?
I don't remember the first one.
Let me look real quick too, because I have
think that was
I
the
have it in my
business.
notebook.
So exercise.
K was the one we're doing, right? K is one of them, right?
Yeah, okay.
Huh?
Yeah, so question number 2 or question number 1.
That's an exercise I, right?
Right. So you can see this question is talking about that right now.
Question 2.
Yeah, the question is saying that, or just 1 or 2. If you look at 1, it's saying a methane gas sample occupies this much volume. So you're given volume and you're given temperature. And then it says if pressure, you see it says pressure held constant. It'll either say that or it'll just not mention pressure. That just means we don't need to worry about pressure.
You just take it out of the equation.
Yeah. We don't need P because it's not changing. So there's no P1, P2.
Mm-hmm.
There's just P1. There's no P2. So we don't worry about it. So, and then it says, what will be the temperature? You see, it says, what will the temperature if volume expands to 10 liter? So you can see clearly you're given 2 volumes.
Mm-hmm.
And that tells you got to use my equation where I have 1 and 2.
So it's just V1, T1.
Yeah, so here now you got to decide
T2.
what is the formula going to be? Is it V1 times T1 or is it going to be
V1 over T1?
V1 over T1, right?
Yeah.
Right.
Okay.
You got that, Nick?
Go over with me. I was a little too fast for me.
What's that?
You went a little too fast for me, honestly.
Oh, okay, so I think you did these problems. And
yeah, I did.
Right.
I just can't find the exercise.
So, yeah, don't worry about it. You can see it on my board, right? You can see it on computer.
Right.
So there's a sample of methane gas that occupies that much volume.
Right.
Now, you have to figure out that this is volume.
Right.
It might not say that word volume on the test. You look at the unit liter and it tells you this is volume. So you're given a volume, and then you're given temperature, 19 degrees Celsius.
And then we have another volume there, which is V2.
And then you're given volume, V2, 10 liters.
So we're trying to divide pressure.
You're trying to find what?
Pressure?
No. Did you read the question?
Oh, it's a sample of methane gas CH4 occupies 3.25 liters at a temperature 19 degrees Celsius. If the pressure is held constant, what will the temperature be if the volume expands to 10 liters?
So what's it looking for?
It's looking for how pressure is going to react with the volume if the volume expands to 10 liters.
So if you read the second sentence again, what does it say? If the pressure is held constant, stop. So if it's held constant, what is that? What is it trying to say?
That we're going to have.
What does it literally mean? The pressure is held constant.
Consistent?
Yeah, it's consistent, right? It's not changing. And remember that we talked about this earlier, like 5 minutes ago? that if
Yeah.
if pressure is not changing or if moles are not changing, we don't worry about it.
Mm-hmm.
Right.
We only worry about the things that are changing.
Right.
So this question could have easily said, or could have easily not mentioned pressure.
Mm-hmm.
Okay. The question could have just said the volume is 3.25, temperature is 19. What is the temperature going to be if volume was 10 liters?
Mhm.
Right? So it could have just
Uh-huh.
skipped that, but it didn't. It just wanted to confuse you by putting the word pressure in there.
Right.
Okay? But you have to be confident with these things. When
Okay.
it's saying pressure is constant, that means it's not changing. That means I don't need to worry about it.
Right.
Okay? So the only thing changing is volume and temperature.
Mm-hmm.
So what is this question looking for again, Nick?
It's
If the
looking
pressure
for.
has held constant, so we don't worry about pressure. So what is it looking for?
We're looking for just temperature
Yeah, so it says what will be the temperature, right?
and
We're
volume,
looking
right?
for T2. It's giving you volume. It's not looking for volume, right? It's
Right.
giving you the volume V2.
Now, in these, depending on the circumstances I'm on, you want us to change milliliters to liters, right?
Yeah, so not you don't always have to change milliliters to liters.
But
You
it's
only
just
have to change
depending on
it.
the circumstances, right?
Yeah, so what do you mean by circumstances? What circumstances do you change it to?
Like, I'm just saying,
Hello.
like how you said, not always. You do it just in various situations. I'm trying to figure out what situation to do that.
Right. So what is the situation when you want all your units to be perfect? When do you want your pressure to be ATM? When do you want your volume to be liters? When do you want your temperature to be? Temperature is always Kelvin, so forget
Right.
about
PV
temperature.
equals nRT.
Yeah, PV is equal to nRT. When you have R,
Yeah, R. Right.
when you have R, you must have correct units.
Right.
Otherwise, it doesn't matter for P and V. They should,
Right.
of course, match. If this is liters, it should match. If this was mLs and mLs, that works.
Right.
Okay. But temperatures, let's say here Celsius, and here temperature, we also want it in Kelvin. We want this temperature to be changed to Kelvin.
Right. So you just add 273.15 to that. That gives
Right,
you.
to this number. Okay. And then you should also know what formula to use.
This one I use. Um,
Again, don't look
V1.
into your notes, okay?
No, I'm not. I'm really
Yeah.
not. I'm
Yeah,
following
yeah.
along with you.
Yeah, uh-huh.
When you use V1 and V2 and T2 in this case, I know you do, but the
So V1
formula,
over T1,
yeah, and then V2 over V or T2. But
V2.
you put T2 right there with V1 and T1, so you can eliminate the T2 right there, right?
Right, so T2, I can take this T2 up here,
Yeah, that's what I'm asking.
right? And then
Yeah,
I have V2, T1 over V1.
V1. Okay. And then once you multiply V2 and T1 and V2, you get the final temperature, and that's what you want, right?
Yeah, that's what we want, T2.
Okay. Um, is this going to be on your YouTube page, Amon, or you're not sure
Yes,
yet?
I'll upload this, yes.
That way I can watch it tonight.
I think it's getting recorded. Yeah, it
Okay.
is. Yeah.
Okay, so, and then let's see again. I just want to make sure I do this problem before I leave again. So V2 is 10 liters, 10 liters, right?
So your
V2, right?
V2 is 10,
10 liters, right?
right? And then temperature
Typed
1.
temperature is 19.0. Or
No,
no, it's that added up, which is 73 divided by that. Let me see my calculator real quick.
it's
I forgot about that because if you do degrees Celsius, it's not going to come out correct.
90.15.
73.15 plus
And then your V1, volume 1 is 3.25.
54.15. Yep. Now I multiply that by 10 and divide that by 32.5. You got 782, and that's my T2, correct?
Yeah, how much did you get? It's something on here,
782.
right? I don't know. Wait. V1 over T1, V2 over T2. T2 is equal to V2 T1 over V1, and then it's 10 liters times temperature.
I'm doing it again too.
Yeah. What did you
Yeah,
get?
I got 898.92 this time. That sounds about right to me.
898
Yes.
point what?
0.92?
0.92 Kelvin.
Right. That sounds about more right to me. I don't know how I got the other one. Probably wasn't doing something right.
V2 T1 over V1. And I'm just wondering. Yeah, so temperature went up. Yeah, all right. Yeah, I'm just thinking that your volume went up, so temperature must have went up. So it did went from 292.15 to 898.15.
Right.
And that kind of sounds right.
Right. So is that answer correct or no? The
Yeah.
amount of Kelvin?
Yeah. Let me just double check on the key.
Okay, go for it. So that's basically when you use the T1, T2, and the V2. Is it the same thing too with P1, P2 basically or no?
Yeah, let me just give me a second, okay?
Hey, I'm back. I lost internet
You're
connection.
oh,
Sorry.
okay. Yep, that should give you the right answer. 898.92, yeah, that's what we got. Yep.
Yeah. So Amon, depending on like in the next one, the torr, that's pressure, right? So we're trying to find when the pressure's changed. So we're trying to find P2 in that case, right? Number 2.
Yeah. So you're given what is this?
That's V1.
Right. And you're given pressure. So it's asking you what volume will it occupy. So it's looking for volume.
Right.
And the
So
pressure
so we
changed
have
to
P1 and P2.
right. So what
So we
equation
have
should we use?
P1 over V1, right?
Think again.
V1 over P1.
No.
They're
What is
both
the
on the same
formula?
side, so it would be P1
Yeah.
V1.
P1 V1 equals P2 V2, and not P1 over V1. It's not always division. When they're
Also, it
together,
could
you
be
multiply.
multiplication and stuff, right?
Right.
Okay.
Yeah. So
And then
you're given volume 1, you're given pressure 1, you're looking for V2, and you're given P2. This is P2.
so to find that, wouldn't I move the P2 as the denominator for that right there?
Right. So that's what you'll do. And after that, you just plug in your numbers. Pressure, do we have to change our pressure from torr to ATM?
It's already done. Yeah, we still do. Yeah, we have to
do we have to?
Only if we're using
PV equals
R,
RT. Yeah, that's right.
Only if you're using R.
So you don't have to in this case.
You don't have to.
Torr the way it is.
Yeah, I mean, even if you do, it's not going to give you the wrong answer. So if you feel like you can if you want, but it's just going to waste your time. So pressure 1 is now. What I'll suggest to you guys is whenever you're doing these questions, especially the one, Steven, you asked me earlier, that P1 V1 over T1 equals P2 V2 over T2, and you isolated T2. That's too much shuffling. So make sure that you make a list of what is P1 equal to, what is V1 equal to, what's T1 equal to, what's P2 equal to, what's V2 equal to.
Okay.
And when you're plugging in these numbers, these variables, be very careful because it's very common that you will mess up somewhere. I've seen students doing that very commonly. That you will, instead of putting V1, you'll put V2 instead. So let's say the question was P1 V1 equal P1 V1 over T1 is P2 V2 over T2. And when you isolate T2, T2 is going to be equal to P2 V2 over P1 V1 and then T1, right? So when students are plugging in P2 V2, or when they say that they need to plug in T1, they will mistakenly add P1 V1 on top.
Oh, so you do okay? So basically, it's like there's a parentheses around P2 V2 over P1 V1.
No, there's no parentheses around. You can multiply the whole thing together. What I'm trying
you
to say is when you're picking from the question that what is P2, what is the number P2,
Mm-hmm.
a lot of students mistakenly pick P1. That's what I'm
Oh,
trying
okay.
to
I
say.
see what you're saying. Okay.
So
That's why you label everything.
that's why you label everything, because
Okay.
you might misplace P2
Mm-hmm.
and P1. That's what
Okay.
I'm trying to say. So just be
Gotcha.
careful on the test that if you have to put in P2, make sure that you're putting in P2 and not
Okay.
P1 by mistake.
Gotcha.
That's one of the common mistakes I've seen on the test.
Okay.
Like, for instance, for this question that we're doing right now, you see that P1 is 1156 and P2 is 912.
Mm-hmm.
A lot of students will confuse this. They'll put 912 on the top and 1156 on the bottom.
Gotcha.
So just be careful about that. That's
I
my
got
point.
2.4 liters for that.
Yeah, so you'll just plug that into a calculator and whatever you get.
I got 2.4 liters for the answer.
Yeah. All right. So guys, I'll end the
Yeah.
video here, and then I'll upload this
Awesome.
on Canvas via YouTube. So Stephen, if you missed like the last 5 minutes, you can
Okay.
watch it again on YouTube.
Awesome. Thank you.
All right.
Appreciate it.
All right, guys.
You'll have one again next week, and you'll do that. You'll do those workshops on Friday, right?
Yeah, on Friday we'll be meeting from 11:30 to 1.
11:30 to 1.
In room
Okay,
505.
sounds good to me. Okay,
Awesome.
thank you.
Thank you.
All right.
Have a good day.
Yeah, you too, man.
Have a good one
You
tomorrow.
too.
Thank you.
You take
Have a nice
care,
weekend.
guys. You
Bye.
too.
See you tomorrow.